Bismillahir Rahmanir Rahim. Today we are speaking about the product of the matrices, and this is the second part of this point. We define the product of the two matrices, that A times B is the product of the row of the first matrix multiplied by the column of the second matrix, provided that the two matrices A and B have the number of columns of the matrix A equal to the number of rows in the matrix B. And in this part, we are going to have more examples about the product of the matrices or matrix multiplication. Now we are given in this example the matrix A and matrix B, and we need to find A and B. We need to find A, B, and B times A. Let's see. The size of the matrix A is, we have 3 rows and 2 columns. Matrix B of size 2 by 3. So the number of columns of matrix A equal to the number of columns of matrix B, which means that this multiplication can be done. It is A times B. We can multiply A times B. And the output will be 3 by 3. We have a matrix of size is 3 by 3. We take the first and last one. So the size of the result matrix will be 3 by 3 matrix. Let's find A times B first. I have 1, 2, minus 3, 3, 1, minus 2. This is the matrix A, multiplied by the matrix B, which is 0, 1, minus 1, 2, 2, and minus 4 is equal to row, then column, row and column. So the first row, 1 times 0 will give me 0, plus 3 times 1 is equal to 3. So the first element will be, or it's coming from the first row multiplied by the first column. First row multiplied by the first column. So it is 0 plus 3. Now let's move to the second column. Second column. I multiply. Now in this case, 1 multiplied by minus 1 is equal to minus 1. And 3 multiplied by 2, it is a plus 6. Now let's move to the third column. 1 times 2 will give me 2. Plus 3 with minus 4 equal to minus 12. Now this is only the first row with the first column, second column, and third column. Now let's go and apply the same thing for the second row. Let's do it for the second row now. For the second row, I have 2 multiplied by 0 is equal to 0, plus 1 times 1 is equal to 1. So it is 0 plus 1. Let's move to the second column now. 2 with times minus 1 will give me minus 2. Then 1 multiplied by 2 will be plus 2. Now let's move to the third column. 2 times 2 is equal to 4. This one with this one. And 1 times minus 4 is equal to minus 4. So we are done from the second row. Let's move to the third row. Now minus 3 times 0 will give me 0. Minus 2 multiplied by 1 is equal to minus 2. So this is minus 2. Let's move to the second column. This one with this one. Minus 3 times minus 1 is equal to 3. And minus 2 plus or times 2 is equal to minus 4. Move to the next one. The last column. Minus 3 times minus or times 2 is equal to minus 6. Again, we are third with the third. And minus 2 with minus 4 is equal to plus 8. This will give me the matrix 3, 5, 2 with minus 12 is minus 10. Down, the second row is 1 and 0. And 0 again. We have minus 2, minus 1, and 2. So this is a 3 by 3 matrix. So this is A times B. So we found the product of two matrices A multiplied by B. Now let's find B times A. B times A. Let's reverse the order. B first, which is 0. 1 minus 1, 2, 2 minus 4 multiplied by the matrix A, which is 1, 2 minus 3. And we have 3, 1 minus 2. 3, 1 minus 2. Now, first of all, let's check the order of the matrices. For the matrix B, it is 2 by 3. This is the order of this matrix B. For A, it is 3 by 2. Now, number of rows of the matrix B equal to the number of columns of the matrix A, which means that we can multiply these matrices B times A. It is possible to find the product of B times A. And the size of the new matrix now will be 2 by 2. It will be 2 by 2. Now let's do it. We'll take the first row with the first column first. 0 multiplied by 1 is equal to 0. Minus 1 minus 1 times 2 is equal to minus 2. 2 with minus 3 is equal to minus 6. So this is the first row, first column. Now let's move to the second column. 0 with a 3 will give me 0. Then minus 1 with 1 is equal to minus 1, and 2 multiplied by minus 2 is minus 4. So we are done from the first row. Let's go to the second row. This 1 times 1 will give me 1. 2 times 2 is equal to 4. And minus 4 with minus 3 is equal to plus 12. Now let's move to the second column of the matrix A. 1 times 3 is equal to 3. 2 times 1 is equal to plus 2. And minus 4, this one with this one is equal to plus 8. So the So that will give me now -8, -5, 17, and 13. And as we said before, A multiplied times B is not equal to B times A. So the product of the matrices is not commutative. So we have to be careful about this point. A times B is not equal to B times A, and as we mentioned before, the size for the output is 2 by 2. One more example. So for that, we have this matrices, or these two matrices. I have A times B. And I need to find A times B and B times A. A, B. Now the size of A is 2 by 2. Size of B is 3 by 2. So number of rows, so number of columns of the matrix A is not equal to the number of rows. So A times B, we can say not possible. Because of the number of columns of A is not equal to the number of rows in the matrix B. So this is A times B is not possible. What about B times A? If we reverse, B times A. B of size 3 by 2. A is 2 by 2. And we can see number of columns of B equal to the number of rows of the matrix A. So this can be done. We can find B times A. So A times B is not possible, but B times A, we can find it. What is equal to? We can find this one. B is given by 1, 3, 0, -2, 1, times the matrix A, which is 2, 3, -1, and 3. This is equal to first row, first column first. So I'll have from the first row, it is 2 minus 6. Now first row, second column, I will have -1, -6. First with the first, second with the second. Now let's move to the second row. 3 times 2 is equal to 6. Think about this one now. Plus a 3. And minus a 3 plus a 3. Second row, second column. And also we have 0, -6. Now third row with the first column. And 0 and -6. Which is equal to, it will be -4, -7, 9, 0, -6, and -6. And this is of size 3 by 3. You can see clearly that the product of the two matrices is not commutative, and to find the output, we have to multiply the number of rows, the rows by the column of the second matrix, one by one. This will give me the new matrix. We can call it C of the size of the number of rows of the first matrix by the number of columns of the second matrix. And that's why we have the 3 by 3. The size of the new matrix is a 3 by 3. It should be 3 by 2. I say 3 by 3, it should be 3 by 2. We have 3 rows and 2 columns. So it is 3 by 2.